Right. So as I said, we'll be looking at significant figures, and then we'll see how we can use these significant figures, okay, to talk about uncertainty. Okay, so these are the objectives here that I've outlined. Okay, we are going to go over the rules for the significant figures, um, and then we are also going to define what uncertainty is. And then once we define uncertainty, we are going to use it to find what we call as the lower and the higher readings. Okay, and then from the lower and the higher readings, we can have what we call as the uncertainty range. Okay, so that's what we're going to do here. So I've got a lot of questions that we have to practice on this same concept. Okay, so we start from the rules of significant figures. Okay, so I was getting a part of your school notes here. So these ones are not actually my notes, but I'm going to use them to explain. Okay, they are for um, the university. Okay, so the first thing we are going to talk about significant figures, okay, and the rules that we use to count them. So if you have any questions, guys, please just unmute your mic and then you can ask. Okay, so we have about 4 rules, okay, that we use to count or to tell if a number is significant or a number is not what? Significant. Okay, so we have about 5 rules that we have to know. Okay, so the first rule here, you can clearly see they're saying all non-zero digits are significant. Okay, so what does that mean? So it means that any number, as long as it's not zero, okay, as long as it's not zero, then that number we're going to consider it as what? Significant. Okay, so you can see here in this example, we have 4.567. So since 4 is not 0, 5 is not 0, 6 is not 0, 7 is not 0, we're going to say this number here has 4 significant figures because each of them will be counted as a significant figure. Okay, so this is the first rule that you have to know. Okay, in the second example, we have 25 milliliters. Okay, the 2 is not a 0, the 5 is not a 0. So both of these numbers are non-zero digits. So we're going to count them as what? Significant. Okay, and then from there, we go to the 3 types of zeros that we have. So the first one is what we call as the leading zeros. Okay, so the leading zeros simply means the zeros in front, okay, or the zeros before non-zero digits. So you can see here, we have these zeros here that are coming before these non-zero digits, okay? Even here, I have this 0 that is coming before this non-zero digits, okay? So what is the rule of significant figures concerning the leading zeros? So the rule is that leading zeros are never significant, okay? So when anywhere where you see a leading zero, just know that that 0 is not counted as significant. It's just there to show the number of decimal places. Okay, so if I write 0.00094, it will mean this number only has 2 significant figures. These ones, they are in front. They are called leading zeros, okay, in front of the non-zero digits. So they are not going to be what? Significant. Okay, and then the second type of zero is what we call as a captive zero, or the arrested zero, or the in-between zero. So these are zeros that are in between non-zero digits. Okay, so you have a non-zero digit on your left, you also have a non-zero digit on your right, and then in between there you have zeros. So what's the rule concerning the captive zeros? The rule is that, okay, the rule is that the captive zeros are always significant. Okay, as long as it's just a 0 between non-zero numbers, then it's going to be significant. So you can see in this number here, it was 56.087. Okay, so this 0 here is between the 6 and the 8, which is non-zero. So it means we are going to consider this 0 as significant. No wonder here when we count the number of significant figures, we are saying 1, 2, 3, 4, 5. Okay, even the 0, we are considering it. Okay, even here, we're going to count 1, 2, 3, 4, because these 2 zeros are between non-zero digits. Okay, so they're significant. Okay, so now the third type, okay, the third type has a rule that you should pay attention to. Okay, so the fourth rule is that is about what we call as the trading zeros. Okay, so the trading zeros are the zeros that come after non-zero digits. Okay, so I can write 5,000 like this. So these zeros that are coming after this non-zero digit here are the one that we're calling as trading zeros. Okay, so trading zeros can be significant or they cannot be significant. Okay, so in what case are these trading zeros significant? Okay, so the trading zeros are only significant, okay, if the number contains a decimal point like this. Okay, so if this number contains a decimal point like this, then I'm going to count these zeros as significant. But if this number is just like this, no decimal point here, then I can't count these as significant. I'm going to say these ones are non-significant. So I'm going to say, therefore, this one, okay, has one significant figure. But this one here with the decimal point there has 1, 2, 3, 4, 5. It has 5 significant figures. Okay, so that's the rule concerning trading zeros. They are only significant if there's a presence of the what? A decimal point. All right, so any questions on the rules of significant figures? Any questions there? Any questions that you have on what I've explained so far? Okay, so if there are no questions, I'm going to continue. Okay, but if you have any question, please uh, don't feel shy. Okay. Um, Someone is saying, kindly say again on one. On one, number one, this one. Number one is the simplest. We said if a number is not a zero, okay, meaning it's non-zero, it's a counting number, okay? It's a number between 1 up to 9 there. Then we say that that number is always what? Significant. That's what we said on the first one there, okay? And then we classified the 3 zeros that we can have, which is the leading. The leading are never significant. Even if there's a decimal point, they are never significant. The captive ones are always significant. The trading zeros are only significant if that number has a what? A decimal point like this one here. Okay, so now how do we connect this concept here for the significant figures? Okay, how do we connect it to what we call as uncertainty? Okay, how do we connect it to what we call as uncertainty? Okay, so when you'll be doing your,
Sorry,
okay, someone has a question?
uh, on number two there, if there were zeros in front of 5,
Mm-hmm.
0.00765, let's say there were 2 zeros in front.
Can you say the number
What,
again so that I write it?
like the first number on the number 2 is
This one. Uh-huh.
0.00765.
Uh-huh.
If there were 2 zeros in front of 5,
Uh-huh.
after 5,
Like this?
how would you treat them?
Uh-huh. So these ones are leading. We say they are not significant, but these ones here will be significant because they are trading zeros and we have a what? A decimal point there. You've seen it? Hello, the one who was asking.
Oh, yes, I get it. I get it.
Yes. Yeah, so the trading zeros here are never significant, but the trading ones that come after the non-zero digits, they are only significant if there's a presence of this decimal point. So since here the decimal point is there, we're going to call these ones here as significant. That's how it works. Okay, so I was talking about uncertainty now. I was saying in any measurements that you are going to be doing, okay, as you'll be going to your labs, very soon you're going to be going to your chemistry labs, physics lab, biology labs, okay? So in those labs, you're going to be making some measurements, okay? Maybe they give you something, you measure it on a weighing balance, okay? So in every measurements that you are going to do, they are going to be uh, there will be some degree of uncertainty. Okay, so what do we mean by uncertainty? We just mean that the actual weight, okay, of whatever you're told to measure. When you put it on the weighing balance there, okay, it won't be the actual uh, reading that will be shown on that measurement. Okay, so for example, if I have maybe I have hydrochloric acid, okay, and I'm saying this hydrochloric acid weighs maybe 2 grams like this, okay. So when I put it on that weighing balance, the reading that I'm going to get, okay, is not exactly 2 grams. Okay, it will be maybe 1.99 grams. Okay, or it can be 2.1 grams. Okay, so it can be a number that is above or a number that is what? Below. So this thing here of not getting the exact weight, okay, or exact quantity of the measurement that you are measuring is what we call as some degree of what? Uncertainty. Okay, that is some degree of uncertainty. So in every measurement, okay, you are going to have some degree of uncertainty, meaning you're not going to get the actual correct reading when you measure that thing. Okay, so here they were saying the number associated with a measurement is obtained using a measuring device. Okay, so these uncertainties arise from these measuring devices that we have. Okay, so if you get the beam balance, maybe you measure, okay, you get the weighing balance, okay, so depending on how it was made when it was manufactured, okay, it will have a certain degree of uncertainty. So in most cases, they actually put the degree of uncertainty on this measurement so that you know, okay, so that if, for example, you measure something, you know something is a 5 kg maybe, so then you subtract the uncertainty to get the correct reading of that thing. Okay, so that's what happened in every measurement that you can make. Okay, so you can see here whatever I was explaining, they're saying the uncertainty of a measurement depends on the what? The precision of the measuring device. Okay, so moving forward now, okay, when you're given any number, okay, or you measure anything and then you get a reading out of it. Okay, so a perfect example is this one that I've been given here. Let's say you measure something on a weighing balance and it weighs 3.7 grams. Okay, so in the number that you're going to get, okay, in the number that you're going to get, one, the measurement is going to experience uncertainty, right? Okay, so in the number that you're going to get, you're going to have what we call as a certain digit, okay? And then you're also going to have what we call as the uncertain digit. Okay, so the balance just gives you that, but you don't trust it because you know there's some degree of uncertainty in that measurement. So we are going to call that number as uncertain digit. Okay, so what is the certain digit and what is the uncertain digit? Okay, so the uncertain digit is always the last significant number that you can see in a measurement. Okay, so the last significant number is the one that we are going to call as uncertain digit. And then the rest, we're going to call them as certain digit. Okay. So now what happens in the case where you have, in a measurement, you only have one significant figure. Okay. So if you have one significant figure in a measurement, then it means that same one significant figure is going to be our uncertain digit. So it's possible that you can get a number where you don't have a certain digit. Okay. So for example, if your measurement measured 30 grams like this, you put something on a balance, then it measures 30 grams. Okay. So according to the rules, we said this trailing zero cannot be significant because I can't see any decimal point here. Okay. So the only significant figure here is this 3, which is a non-zero. Okay. So according to the rules of uncertainty, we say the uncertain digit is the last significant figure. So if you only have one significant figure, then it means that's the uncertain digit. So in this case, our uncertain digit will just be what? 3. This will be uncertain. So it means in this measurement, we're not going to have any certain digit. Okay? We're just going to have an uncertain digit. So it means that measurement of ours is uncertain. We are not sure of it. Okay? All right, so if there are any questions there, you can ask, okay? And then let's say you measure something, maybe 30.2, okay? So here, which one is the uncertain digit? Okay, so we said the uncertain digit is the last significant figure. Okay, so the last significant figure here is this one. So we're going to call this 2 as our what? Uncertain digit. And then the rest here, they're going to be certain digits. Okay, what if we have another measurement? Let me write it like this: 312.5.0050. Okay, so which one here is the uncertain digit if you are following what I'm saying? Which one from this number here is the uncertain digit? Anyone can try. Hello? Anyone who can try. Which one is the uncertain digit there? If you're following my
Maybe the
explanation.
last zero.
Exactly. Okay, so the uncertain digit here will be this one, the last one. Okay, because that's the last significant figure that I can see in this number. Okay, so don't be confused when you're given questions. Just take your time, process this rule that I'm telling you here. Okay, because it's going to save your life. So the uncertain digit is always the last significant figure. Okay, so if you only have one significant figure, then that same number becomes the uncertain digit. Okay, to mean that we don't have any certain digit in that number. And then in this case, like this number, the last significant figure here is 0. So this trading 0 is significant because there's a decimal point there. So it means all these numbers here that are before this uncertain digit, these ones we are going to call them as what? Certain. Okay, so that's the rule there. Okay, so knowing your uncertain digit will help us now. Okay, will help us now find the range of uncertainty. Okay, because from the uncertain digit, we'll be able to come up with the lower reading, we'll be able to come up with the higher reading, and then we are going to come up with the uncertainty, and then it can also help us find the what? The range of uncertainty. So that's what I want us to focus on here. Okay. All right, so moving forward, this was an example here. They're saying significant figures automatically indicate something, okay, about uncertainty in a measurement. So the uncertainty in the last digit in significant figures is usually assumed to be plus or minus 1, unless otherwise indicated, okay? But you're going to see that as we will be solving these questions, okay, it's not always plus or minus 1. It can be plus or minus 10, plus or minus 100, plus or minus 0.01, plus or minus 0.01. So it all depends on the position of the uncertain digit, okay? And then here, there's one important quote there, okay? So they are saying here, the greater the number of significant figures in a measurement, okay, the greater the certainty. So this one here is a question that will come, okay? I don't know if tutorial sheet 1 is yet out, okay? But I suspect because in the previous intakes they have been putting it, okay? They're going to ask you a question about this. Okay, so they will give you two measurements. Let's say, for example, 30 grams and then 30 point grams. Okay, so according to what we've learned today, we said this one here only has one significant figure because there's no decimal point. This one here will have two significant figures because the 3 and the 0 will be significant because of this point here. Okay, and then they'll ask you which of these two numbers here is more certain. Okay, so that answer to this question will just come from this statement. Okay, so you're going to say this one is more certain because it has more significant figures. And then this one here is less certain because it has fewer significant figure. Okay, so take note of this statement here. Very important. Okay, so now here they're saying example, volume recorded as 25 milliliters. Okay, if you consider uncertainty in measurement, it means volume is between 24 milliliters and what? 26 milliliters. Okay, so now the question is, how did they get 24 milliliters? And again, how did they get 26 milliliters? Okay, so the number that we have here is 25 milliliters, right? Okay, so to get this lower reading, because this one here, we just call it the lower reading. This one here will be the upper reading, okay? So to get this lower reading and the upper reading, we have first of all to identify the uncertain digit here. Okay, and then based on the position of the uncertain digit, we are going to find our uncertainty. Okay, and then to find the lower reading, we're just going to say the given reading minus the uncertainty. To find the upper reading, we're going to say the given reading plus the uncertainty. Okay, so let's do that. Okay, so let's do it together. So which one here is the uncertain digit according to what we've learned? Which one is the uncertain digit there?
It's 5.
Exactly. Excellent. Okay, so 5 here is the uncertain digit. Why? Because it's the last significant figure in this number. So it means this 2 here is actually the certain digit. Certain. Okay, so once we identify our certain, our uncertain digit, I mean, okay, based on its position, we are going to get what we call as the uncertainty now, this one here. So how do you get the uncertainty now? Okay, so we'll go back to, I don't know if that was grade 1 where we had the abacus. You remember the abacus? I don't know if that was grade 1 or something. Okay, so the abacus was something like this. Okay, so the abacus, something like this. Okay, I can have others here again. Okay, so what we were doing on that abacus, okay, what we were doing on that abacus, we are naming these things as, let me put a decimal point somewhere here. Okay, so let's say here there's a decimal point. Okay, so we're saying that these ones here, okay, according to the abacus, if you remember it, we are saying these are ones. Okay, these we said they were what? Tens. These ones here, we said they were hundreds. And then here, we said they were what? Thousands. Like that. You remember? The abacus. Okay, so we're just playing with the abacus, but it's going to give us a way to determine the uncertainty. And then we said after the ones, when we go to the right-hand side of the decimal point, we're going to have tenths here. Okay, tenths, like this. Okay, and then here, we're going to have hundreds. Okay, so hundredths, like this one here. And then the last one here, we were calling it as thousands, like that. Okay, so what does this mean here when we actually talk about the actual numbers? So if a number is in the ones, we'll just write ones. If a number, if the uncertainty, if the uncertain digit is in the ones here, then the uncertainty becomes plus or minus 1. If the number is in the tenth here, the uncertainty becomes plus or minus 10. If the number is here in the hundreds, the uncertainty becomes plus or minus 100. If it's in the thousands, it becomes plus or minus 1,000. This will be our uncertainty. Then to the other side of the decimal point, these are tenths. So it means here it will be 1 over 10, which is 0.1. So here it will be plus minus 0.1. Here to be plus or minus 0.01, because this one is the same as 1 over 100, like this. Then here to be plus or minus 0.001, because this one is the same as 1 over 1,000. So you should check on your calculator that this gives you this gives you this gives you that. Okay, so this thing here, the abacus, is what we are going to be using, okay, to get the uncertainty. So the number that we were given there was 25. And we said the uncertain digit is this one, the 5. Uncertain. Okay? So if the 5 is uncertain, okay, now you identify the position where it is in that number. Okay? So this number is 25. So it means this one here is in the tens. Okay? It means we have 25 like this. So the 2 is in the tens. The 5, let me write it properly. The 5 here is in the what? Is in the ones. So the uncertainty Okay, because the uncertain digit is in the ones here. The uncertainty, okay, the uncertainty, we're going to say it's equals to plus or minus what? 1. No wonder here, the lower reading, they just said 25. Lower reading, they just said 25 minus 1, which was 24, right? Okay. Upper reading, they said the upper reading was just 25 plus 1, which gave us 26. These were the answers that we got, right? So meaning that we can even calculate now the uncertainty range. So uncertainty range will just be equals to the upper reading, which is 26, minus the lower reading, which is 24. So the uncertainty range here will actually be 1, like this. Okay? All right, so any questions here on how to get the uncertainty and the lower reading and the upper reading? Any questions there? Okay, if there are no questions, let's try to look at questions now. Okay, let's try to juggle with these things. Let's try to look at questions. So question 1, this one here. Okay, so we'll start from identifying and then all the way up to finding the lower, upper uncertainty range. So this one, the first one, they're saying, considering uncertainty in measurements, which digit is uncertain in the um, measurement recorded as 1200 grams. So this question will be answering together with you. Okay, so Rita, you are writing on my board there. Let me disable annotations for you guys. Okay, so in that number there, which digit is uncertain? Anyone? Which digit is uncertain in this number here? Hello?
It's true. Two is uncertain.
You're
The
saying
last
what?
zero.
You're saying
The last
what?
zero.
You're saying the last
Last
zero.
zero. Yes.
Okay. So the answer there, what you've said is not correct.
Two.
So anyone else?
Two is uncertain.
Which one is the uncertain digit there?
Two is the uncertain digit.
Exactly. Okay. So the other one who said 0, you didn't understand what I said. We said the uncertain digit is always the last significant figure in a given number. Okay. And then we also looked at the rules on how to count, okay, the number of significant figures that you have. So these two zeros here, these zeros are trading zeros. Okay. They are not significant because there's no decimal point here. Okay, they're not significant because there's no decimal point here. So meaning the only significant figure that I can see here is 1 and 2. So between 1 and 2, which one is the last significant figure? It's this 2 here. So we're going to say the 2 is our what? Uncertain digit. Okay, so the certain digit here will just be this one here. The uncertain digit is going to be this 2. That's what we said. Okay, so the uncertain digit there is just 2. Okay. The certain digit there is just 2. Okay, so what if they twisted this question a bit and then they said the measurement was recorded as 1200 point? Okay, so if they put a point there, then it changes everything. Then it means these two zeros now are significant. So which one between these two zeros is the last significant figure? It's the last zero, right? So we're going to say the uncertain digit in this case will be this 0 if there was a decimal point. Okay, next. Now here there's the answer. So people will answer fast. Anyway, so here they said the concentration of zinc in milk sample was recorded as 130. Okay, consider the uncertainty in measurement. Which digit is uncertain in the given measurement? Okay, we said what? The last significant figure here. No wonder the answer there was just 3. Okay, because this 0 is not significant. There's no decimal point there. Okay, next, here they're writing, okay, so this one is very nice. So let's do something like this. Where is the Okay, so hey. Oh, okay. So here they're saying the concentration of iron in a powdered milk sample was recorded as 800, okay, milligrams per grams of zinc. Okay, so the question now is which digit is certain in the recorded measurement? This one. Which digit is certain? Anyone who can try. Which digit is certain here? Which digit is certain there?
There is no certain digit
Okay, so why are you saying there's no certain digit there?
because only 8 is a significant figure and 8 is the
Exactly.
first one.
Excellent. Okay, because this number here has one significant figure. So in my explanations, I said if you have one significant figure, then you don't have any certain digit. Okay. Okay. We only have the uncertain digit. Okay. So the uncertain digit here is this 8. Because why? It's the last significant figure. Okay. There's only one significant figure. So meaning it will also be the last significant figure. So this 8 here is uncertain. Okay. So there is no certain digit there. Okay, no wonder the answer there was none of the above. I even hid it here. You guys didn't see. I put something here. So the answer there was none of the above. Because there's no certain digit here. There's just the uncertain digit, which is this one. Okay, next. I think this is similar now. The concentration of zinc of milk was recorded as 130 point. You can see like a point there. So be careful as you see the questions. There's like a point there. Okay, so there's a point here. So meaning here we are counting this 0 as significant. We are counting this 3 as significant. We are counting this 1 as significant. So the last significant figure here is what? Is 0. No wonder here they're saying what digit is uncertain. Okay, so the 0 becomes the uncertain digit because it is the last significant figure. Okay, because it's the last significant figure. All right, and then the certain digit will just be 1 and 3. Okay, another one. Uh, Here they are saying what? Okay, so this one is the same as that one for 800. So we have 300 here. And then they're asking you which digit is certain here. There's no certain digit here because this one is the only significant figure. So it acts as the last significant figure, which means that it is what? Uncertain. So there's no certain digit here. Right. I hope you've gotten that concept. Okay. And then now we can move to this type of questions now where we're finding the higher reading, the lower reading, and also the the range. Okay. All right. Let's do this one. So this one, they're saying a measurement was recorded as 175 milliliters. Considering uncertainty in measurement, okay, A, indicate the higher reading. B, indicate the lower reading. C, indicate the range of uncertainty. Okay, so which one is A? A, they said what? Indicate the higher reading. B, okay. So for us to indicate the higher reading or the lower reading, and again find the range of uncertainty, we first of all have to identify the uncertain digit. Okay, so we count how many significant figures we have here. We have 1, 2, 3. So it means this 5 here is the last significant figure. So this one is going to be uncertain. Okay, and then from the uncertain digit, we look at the position where it is. Okay, so these ones here are just ones. If we go back to our abacus, where is it? Okay, so that one is just, it was 5, 7, 1. So it is in the ones. Okay. So if the meeting cuts, just rejoin using the same link. Okay, just rejoin using the same link. So this 5 is in the ones. So meaning the uncertainty is just what? Plus or minus 1. Okay, so let me move that slide to somewhere there. Okay, I can even move it there. Okay, so it means the uncertainty there is just plus or minus 1 because the uncertain digit is in the ones. Okay, so once I have my uncertainty, okay, what am I going to do? I'm going to use it to find the lower reading and the upper reading. So the higher reading will just be 175 plus 1. The lower reading, okay, so we are saying the lower reading is just going to be 175 minus 1. So here I'll get 176. Here I'll get 174. Okay, so meaning this is my A, this is my B, and then C, it will be range of uncertainty. Okay, so the range of uncertainty is equals to the higher reading minus the lower reading. This will just be 176 minus 174. So here it means the range will be what? Will just be 2 milliliters. And we are done with this one. Okay, let's look at another one. So the other one, they're saying a measurement was recorded as 75.0 milliliters. Okay, so there's a point there. Okay, so the first thing before we can answer any of these is to identify the uncertain digit. Okay, so the uncertain digit is the last significant figure. So here, since there's this decimal place, then this trading zero will be significant. So meaning to be the last significant digit, right? So the zero is the uncertain digit. Okay, so now based on the position where the uncertain digit is, it's going to give us the uncertainty. Okay, so what is the uncertainty in this case? Okay, so if you go to your abacus, okay, if you go to your abacus, this one, we now have a number there. Okay, we have 0 and then point, and then here we have 5 and then 7. Okay, so here after the point, these are tenths, okay? And they're indicated by plus or minus 0.1. So it means here the uncertainty is plus or minus 0.1, like that. Okay, so now let's find the higher reading. So A, higher reading will just be what I have there, 75.0 plus 0.1. So that is going to give me 75.1. Okay, lower reading, it will be 75.0 minus the uncertainty. So this will be what? This will be 74.9. Okay, so you should remember to include the units there. And then C, we're looking at the range. So range of uncertainty is equals to just be the higher reading minus the lower. So the lower is what? 74.1. So punch this on your calculators. I am getting 0.2 milliliters. Okay, so that's the uncertainty there in that question. Okay, let's look at another one similar to this. Okay, it's here. So this one here, they're saying a measurement was recorded as 75.00 milliliters. So let's first identify the uncertain digit. So the uncertain digit is the last significant figure. So since there's a decimal point here, it means these two zeros are significant. Okay, so the last one is this one. So this is the uncertain digit. Okay, this is the uncertain digit. So how are we going to get now our uncertainty? Okay, so our uncertainty is going to be equals to, we look at where is this uncertain digit? Okay, so before the point, these are ones, these are tens, these ones here are tens. Okay, let me write it properly. These are tens, and then these ones here, okay, 100. Okay, so in the tens, we said 0.01. I mean 0.01, 0.1, like this. Okay, and then in the hundreds here, it's just going to be 0.00. In fact, 10 is going to be 0.01 like this. Okay, so it means the uncertainty based on the position where this uncertain digit is here, it's just going to be 0.01 like this. Okay, so I forgot the plus or minus in front. So plus or minus 0.01. So now to find the higher reading or the upper reading, we're going to say 75.00 plus 0.01 is equals to. So that will give me 75.01 milliliters. Okay. Lower reading is going to be 75.00 minus 0.01, which will be equals to what? Should be equals to 74.99, I mean, milliliters. Okay. So if you have any questions, please guys feel free. And then the range of uncertainty to be higher reading minus lower reading. Okay, punch this onto your calculator. You should be able to get 0.02 milliliters. Okay, so any questions there on these ones that we have done so far? Any questions there? Okay, no questions. Let's look at some more examples. Okay, so this was actually your exercise in your notes. If you started reading the notes that they sent for you at the university. So I just got these questions from the lecture notes. Okay, so make sure you solve these ones. So let's solve them together. So they're saying considering uncertainty in measurements, indicate the higher reading, indicate the lower, and then C, indicate the range of uncertainty. So when I look at 4, 6, 7 meters, all these are significant. Okay, so the last significant is this one. So this one will become my uncertain digit, right? So it means the uncertainty, okay, the uncertainty there will just be equals to plus or minus. So this 7 here is in the ones because this is 1, 10s, 100s. So the uncertain digit is in the what? In the ones. So the uncertainty is plus or minus 1. So it means here on number 1, the upper reading will just be this plus 1, which will give me what? 468. The lower reading, okay, will be 467 minus 1, 466. Okay, don't forget to include the units there, the meters. And then now, range of uncertainty will just be higher reading minus lower reading. This will give me what? Okay, this will give me 2, right? So it give me 2 here when I subtract them. So this is the range of uncertainty, okay, which is just 2 meters. Okay, what about this one here? Interesting one. Okay, finally we have a bigger number. Or maybe I should leave this, okay? So the next one now is 7800 centimeters. Okay, so which one here is the last significant number? So the last significant number is this one here. So these 2 zeros are not significant because I can't see any decimal point there. Okay, so this digit here will be uncertain. So it means my uncertainty. Okay, what will be my uncertainty? Anyone to try? What would be my uncertainty based on that? Anyone? What would be my uncertainty? Come on, guys. What would be my uncertainty there? If you are following, what would be my uncertainty there? Okay. So the first thing is just to label these numbers. Okay, so this one is the number before the decimal point. There's no decimal point here, so it means after this you have decimal places. So these ones we are saying they are ones. These ones here they are tens. These ones here they are hundreds. These ones here they are what? Thousands. Okay, so we said the uncertainty in ones is just plus or minus one. The uncertainty in tens is just plus or minus 10. The uncertainty in hundreds is just plus or minus 100. In thousands, it will be plus or minus 1,000. Okay, so depending on the location of the uncertain digit. So the uncertain digit, which is 8, is under what? Hundreds here. So it means the uncertainty will be plus or minus what? 100. Because this one is in the hundreds there. Okay, so now we can get the upper reading by saying 7800 plus 100, which will just give me what? 7900 centimeters. Lower reading to just be 7800 plus, oh, minus there, because it's lower, minus 100. This will be 700 centimeters. Okay, meaning the range of uncertainty will be the upper reading 7900 minus the lower reading 700. So this one will give me what? Okay, the 7,000 will go. 900 minus 700, this will be 200 centimeters. Okay, so that would be the uncertainty range there. Okay, so any questions there? Okay,
It's clear.
all right, amazing. So we can, in fact, let me just leave this. Okay. So this one here, you can try it out. This one here, you can actually try it out. Okay. So I'm very sure in the tutorial sheet, there's a question, something like this. Okay, it's always there, tutorial sheet 1. I don't know if you've seen that tutorial sheet. I'm just seeing it on my phone. It has popped out here. Someone has sent in the group, tutorial sheet 1. So you expect a question on something like this from the tutorial sheet 1. Okay, so let's look at this. So they're saying the concentration of calcium in milk sample was recorded as 380 parts per million. This ppm means parts per million. Okay, so we have 380 points. So make sure you see this point. Okay, so this one simply means that this one is significant, significant, significant. So the last significant figure here is this 0. Okay, so this 0 is where it is in the ones. These ones are the tens, these ones are the 100. So it means the uncertainty here will just be what? The uncertainty here will just be plus or minus 1. Because the uncertain digit, this one here, is in the ones. Okay, so once we find the uncertainty, we can come up with the higher, lower, and the range. But there are also these questions here. So the first one, they say indicate the certain and the uncertain digit in the measurement above. Okay, so the uncertain is the 0 because it's the last significant figure there. So the uncertain is the 0. So the uncertain is the 0, and then the certain digits. Okay, the certain digits will be 3, 8. So the 3 and 8, they are certain. And then the 0 is not certain. So it's uncertain. Okay, and then now B, the same consider the uncertainty in measurements. Okay, determine the higher. So to determine this, we said you always have to find the what? The uncertainty. So the uncertainty here we found is plus or minus 1. Why? Because the uncertain digit is in the ones there. Okay, so now we can determine number 1, higher reading, which will just be 380, okay, 0.1, plus 1, I mean. So this will be 381, okay? And then lower reading, so just be 380 minus 1. This will just be what? To be 379, okay? So this was 2. And then determine the uncertainty range, okay? Uncertainty range. This one will just be upper or higher minus lower. So this will be 381 minus 379. So this will give you what? To give me 2. Okay? What's the median? So this is my uncertainty range there. Okay, so any questions on this one? Okay. Yeah, so I hope it's clear. So I have some other questions here that you can try out on your own. I'll show you. Okay, so you can be screenshotting. So this one here, try it out on your own. Okay, you find, and then if you have any challenges, please inbox me. Okay, so that I can explain to you nicely. Okay, I also have this question here. Okay, so take note, this one has a point at the end there, so it changes how you look at it. Okay, another one, this one is just like the one we solved because it was 380 points something. Okay, so there's also this question here, this question. Okay, I'll send the video once I'm done. Okay, so that's all for the questions there. Okay, so we've learned significant figures, okay, and how to use them when we are determining what uncertainty in measurements. Okay, so it means in topic 1, we actually have covered almost everything. It's just the errors, accuracy, and precision that is remaining. Okay, so the next time that we have chemistry, we're going to have a lesson. Okay, we're going to have a lesson on accuracy and precision and errors. Then we'll be done with topic 1. Okay, so I'll announce in the group when we have another lesson in chemistry. Okay, so otherwise, our free lessons continue. Okay, the free lessons continue. We started on Monday, we had math. Yesterday, you had physics with Tutor John. Today, you have had chemistry with me. Tomorrow, you're going to have biology with Tutor John. Okay, and then the other days I've forgotten, but I think I shared the timetable in the group, so you can check it there. Okay, and then for those who are ambitious and want to start learning, okay, we have a website that I can show you here. So the website has lessons on basically all the topics that you will learn. Okay, so if you log in, so you just go on Google, you search discretelearning.com. Okay, you create an account there if you don't have an account. It's just simple, like the way you open Facebook. You just create an account, you put in your details there. Open an account, and then it will open something. You see something like this. So here we have the sliding session here. It just tells you what we do. Okay, so we are saying this site is your academic success, okay, because here you find whatever you want in one place. Okay, you can watch topic lessons, tutorial sheets, and past paper videos just here on the website. Okay, and we also have a mobile app for those who are using Android phones. On the mobile app, you can download the videos, okay, and you can watch them offline wherever you are, okay, on the mobile app. Okay, so here you can see download and watch videos offline. So this one here, you can't do it on the website, so you do it on the mobile app. Okay, so if you need the mobile app, send me your email. I add you, and then you can install it, and then you'll be able to access whatever you want. And then you can also make payments anytime, anywhere. We don't have to be there for you to make payments. You just go on the website, you register for any course that you want. Okay, so once you come down here, there's mathematics, chemistry, physics, biology for you who are doing pre-meds. Okay, but we offer a lot of courses. Like this is higher math for those who are interested. Once you are done with pre-meds, you start learning like biochemistry, human anatomy, all these things, we have them here. Okay, so if we go in chemistry here, okay, you're going to find 4 folders. So this is your semester 1. This one here is for your semester 2. So meaning your seniors here. Okay, they will go into this folder. But for you, you just go in general chemistry. You find tutorials, lessons. So here you find lessons and notes on each topic that you can think of in chemistry when you go here. So when you open, okay, you can see introduction to chemistry, units and measurements. Whatever I was teaching here is already here. Atoms, whatever topics you're going to do, all these things here, they're already there. So you can learn at your own time, at your own pace. And then when you move out from there, You can find handwritten notes here, well explained. Okay, so you open, you read, then if you want to read the notes, here you find the tutorial sheets. So under tutorial sheets, okay, you go in the folder for your university. Okay, so we offer lessons at different university. So for you, Apex, you go more Apex. So you're going to find things for Apex. Okay, so I arranged them according to the topics. Okay. So for you guys, since I've seen tutorial sheet one there, I'll put 2025 July intake there. So that's where you'll be finding your tutorial sheets. Okay. But the concept of the same, meaning you can learn even the videos here, there. So you can go 2025. Okay. You're going to find written solutions. For those who prefer written solutions, they are there. Okay. Tutorial sheet one up to tutorial sheet 9. And then the videos, we also have them here. We have what now? We have a tutorial sheet. We have the assignments, first of all. Assignment one is there. You can see very soon you're going to be given an assignment in chemistry and physics. Okay, but in math, there are no assignments, and biology, I doubt. But physics, chemistry, you're going to be given. So you're required to submit that assignment and submit correct answers, okay, because it's going to help build your CA. So you can see the videos and tutorial sheets here, right? So each tutorial sheet is based on a certain topic. So tutorial sheet one is units and measurement. Two, it's stoichiometry. Three, you go deeper now into stoichiometry, where you'll be talking about solutions, stoichiometry, just like that. Okay, so you can access all these on the website as well as the mobile app. And on the mobile app, you have an advantage. You can download the videos and watch them anytime. Okay, I think that's all for today. So if you have any questions, you can ask me before I end the class. Do you have any questions? Any questions? Okay, so if there are no questions, thank you so much for attending, and we'll meet next time.